starting with number 5, it says in exercise 5 and 6, find the measure of each angle in the isosceles trapezoid. Should I zoom in a little bit? Okay, so it says these two are isosceles trapezoids. So remember, in an isosceles trapezoid, these two sides are the same measure, and then also the base angles are the same measure. So these two angles are the same, and then these two angles are the same. And then because you have those parallel lines, this is parallel to this, you have parallel lines and a transversal, meaning that the consecutive interior angles are supplementary. So that's what we need to know for these problems. So for number 5, it shows one of the angles as 118. It does say it's isosceles, so that means this base angle right here is also 118 degrees. And then the consecutive interior angles are supplementary, so we can do 180 minus 118, 62. And that means this right here is 62 degrees, and then this is 62 degrees as well. Okay, and then number 6, same idea. Base angles are the same measure, so if this is 82 degrees, so is this. And then the consecutive interior are supplementary, so 180 minus 82 is 98 degrees. So this will be 98 degrees and 98 degrees. Okay, then for 7 and 8, find the length of the mid-segment of the trapezoid. Remember, the mid-segment is the average of the two bases, or like the middle number. In this one, honestly, we could see that 14 is a middle of 10 and 18, so we could just put 14. The way to do it with math, if you have numbers that aren't easy to see the middle, you just add those two values, divide by 2, and you can find the middle. So 28 divided by 2 is 14, and that is the answer we got. The other way you could, well, I'll wait for that. Never mind. Okay, next one, 8. So we're trying to find the length of this mid-segment right here. Again, just find the average of these two numbers, 76 plus 57, divide by 2. 76 plus 57 is 133. Divide that by 2, you get 66.5. So that is the length here. Nine and 10 are a little bit different. They give you the mid-segment and they want to know the other side. So we'll just call this x. And then this plus this divided by 2 equals the mid-segment, which is 7. So we can do 10 plus x divided by 2 equals 7. And then we can solve for x. So multiply both sides by 2. Multiply this by 2. 10 plus x equals 14. X equals 4. So 4 is the answer here. The other way you could figure that out if solving equations like this is hard for you is look at the difference between these two numbers. You're adding 3 here to get to 10. So to get this bottom number, you could subtract 3 to get the length here. So that could also work as well. Okay, then 10 over here, same idea. Use x here. This plus x divided by 2 equals 18.7. 11.5 plus x divided by 2 is 18.7. Yes, just practice solving. By the way, I don't know if you've heard, but algebra 2 is pretty much just algebra 1, but with harder problems. So this is good practice for algebra 2. 18.7 times 2 is 37.4. X equals 25.9. Is that rain or the air? Okay, we get 25.9. The other way to do this, again, you could subtract these two numbers. 18.7 minus 11.5 equals 7.2. So you're subtracting 7.2, and then you could add 7.2 here to get 25.9. That would work as well. Okay, next page, kites. Or not that. Next. Okay, kites over here. Before we get into these practice problems, there's one I want to bring up that's on the homework. So just above this area here, we're going to draw a kite. So drawing a kite like this. Okay, here is a kite. Here are the diagonals. Remember, the diagonals are perpendicular. And then they tell you, okay, this is, let's say 4, and this is 6, and they want to know the length of this here. So the way you can do that is by using Pythagorean theorem, which is a squared plus b squared equals c squared. A and b are the legs of the triangle, so that would be like 4 squared plus 6 squared. And then c squared is just x squared. 4 squared would be 16 plus 36, 52. This comes up in next chapter as well, so it's a good practice. And then sometimes the answers in the answer choice are just like this, square root of 52. Sometimes they have a decimal. If you do 52 square root in the calculator, it comes out to 7.211. So 7.21 about. And that is the answer. And then, of course, always make sure that's logical. It should be longer than the 2 legs the hypotenuse should be. Okay, so that is one type of problem that you need to know. And then for 15 through 18, we look at angle measure. So something to recall is that for a quadrilateral, the angle measures add up to 360 degrees. So we're using that fact to help us here. It says find the measure of angle G, and it shows us kites. Remember, in a kite, these two angles are the same measure, so we can use that to help us as well. So for 15, take all the angles add up to 360. So subtract 100, subtract 40. That comes out to 220 degrees, but that has to be split evenly among these two angles. So the next step would be 220 divided by 2 equals 110 degrees. So this is 110 degrees, and this is 110 degrees. Okay, 16, very similar problem. These two angles are the same measure. This little box here means that this is 90 degrees. And then 360 minus 150 minus 90, 120 left over. Split evenly among these two angles, so 120 divided by 2 is 60. So you get 60 here and 60 here. '17 and 18, they switch it up on us a little bit. This angle is the same measure as this one, so this would be 110 degrees. And then we're just trying to figure out what G is here, which would be 360 minus 60 minus 110 minus 110, and whatever's left over will be G. And it is 80 degrees, so G is 80 degrees. And 18, same thing. They show this little box here, meaning this is 90. That means this is 90 because these two angles are equal. And then 360 minus 90 minus 110 minus 90 equals 70 degrees. So this is 70 degrees. And that is all. So that is the end of the packet actually. So you can turn it into the basket. Keep your quadrilateral family tree out so I can come around and grade it. Use this time now to get your homework done. If you finish your